Well, welcome to this first DaprCon, and it's fantastic to have all of you join us today. My name is Mark Fussell, and I'm a Dapr maintainer and a member of the Dapr Steering and Technical Committee.
My name is Yaron, and I am a Dapr maintainer and also a member of the Dapr Steering Committee.
So today, Yaron and I are going to spend some time discussing why Dapr was created, some of our favorite features and capabilities, what we're seeing in the community with its growth and engagements, and then some of Dapr's future directions. And in this keynote as well as the rest of the conference, we're going to be hearing from several other companies why they're using Dapr and some of their contributions. So Dapr was publicly released in October of 2019. So this month, we're celebrating its second anniversary, which is why we're super excited about having this DaprCon. And so Yaron and I thought it'd be great to give our perspective on what are the problems first that Dapr is solving for developers building scalable distributed applications. In other words, we thought we'd start off and share what is the why of Dapr. So why don't you kick it off, Yaron?
Yeah, thanks, Mark. If you really think about what Dapr is offering developers, it's a set of APIs. And these set of APIs are really targeted at making developers' lives easier when writing distributed applications. And, I know that oftentimes we talk about Dapr in the context of microservices specifically, but it's also really important for me, at least, to share here that Dapr can really be used from any kind of application, right? So you can use it from a microservice or a monolith, or really from any kind of app. And these set of APIs are meant to make your code portable between environments, so between on-prem environments and different clouds. And it's also meant to make your code reliable and resilient to failures. And these are really the core tenets of all of the Dapr APIs and the capabilities that it offers developers. And so if you look at modern architectures today, where you have lots of services communicating in an environment which is not oftentimes stable in terms of network or reliable connections, Dapr really inject these cloud-native capabilities like retries and connection resiliency and mutual TLS for service-to-service calls, and then also gives you components that you can talk to via Dapr, and Dapr will basically handle all of the hard stuff that developers usually face when writing their services. That also gives them a lot of code portability because you can move your code between clouds, and it'll also just work on your local development machine. So that's really the why of Dapr, just to have developers focus on their core logic instead of focusing on infrastructure concerns.
Yeah, and in fact, going on to that point, I think the way I like to think about it is the way that Kubernetes brought a set of consistent APIs to operators. We think we're doing the same thing with Dapr, where developers instead can have a set of consistent APIs for that code portability. And that way, that consistency, I think, will elevate them to be able to build applications that run on many different environments. So what about some of the background of Dapr? How did it first start?
Yeah, so as for how Dapr got started, in 2019, my then manager, Hai Shibai, and I were working for Mark Russinovich, CTO of Azure, and we were exploring the concept of an application model that gives developers and operators an easy way to deploy and tie together a bunch of services that make up an application. And at some point, we realized that developers need much more than a deployment model, and we want to research and challenges that developers are facing when writing their applications. And that's when we created a proof of concept that gave developers a set of HTTP and gRPC APIs to just make their development easier in platforms like Kubernetes. It was initially called Reactive, then renamed to Actions. And at that point, Mark Russinovich created an incubations team, and Dapr was really its first major project. Then you, Mark, came along from a different team that was exploring the same problem. And together we open sourced Dapr, which is an acronym for Distributed Application Runtime, in October 2019.
Yeah, that's a great story. And yes, bringing together those two teams, we had both experiences with building these distributed applications, seeing the types of problems that developers are having, using it both internal and external, and we'd seen many of these problems. And so we saw that there was a commonality that people wanted to have in terms of building these distributed apps, and something like Dapr would neatly fit into making them productive. So why don't we hear from the first of our companies? Let's hear now from Mark Russinovich, who is the Microsoft Azure CTO and has been deeply involved with Dapr from its inception, to share his perspective on Dapr and the investments that Microsoft is making.
Enterprise developers are being asked to do more than ever. On top of solving their business problem, they need to do it by leveraging cloud services. They need to create scalable, resilient, secure applications. They need to use microservices and containers to do service discovery, to have monitoring and logging. They need to be able to use cloud services, and on top of it all, they're being asked to make applications that are portable between different clouds or on-premises in the cloud. It's all a bit overwhelming. The emergence of programming models like functions as a service and actors show the promise of the platform taking some of the burden away from a developer, providing resiliency built in, providing service discovery built in, but they don't go all the way. What we recognized when we came up with the Dapr vision inside of the Azure Office of the CTO was that by leveraging a sidecar pattern, we could offload a lot of the complexity to sidecar code, the Dapr, the distributed application runtime, which could address things like providing the mechanisms for functions as a service or actors, but allowing a developer to use whatever language and code they wanted to use, and to provide building blocks that would solve common challenges like service discovery for service-to-service invocations, and abstract even classes of cloud services like pub, sub, and storage, so that code wouldn't have to use SDKs, where developers wouldn't have to learn each cloud provider's service idiosyncrasies, and their code would be portable out of the box. It's 2 years since that idea, and Dapr has now graduated from an incubation into a product team here at Microsoft. It's also got a thriving open source community behind it, and many customers now using it in production. We're so proud of what Dapr has become, and we're so excited that this community is built up around Dapr to take it to the next level. We're just getting started, and thanks for joining us.
Well, thanks, Mark. Yaron, let's now talk about the what of Dapr. Dapr has a set of APIs that we call building blocks that include things like service-to-service invocation, publish and subscribe, bindings to interact with external systems, observability. And those are the APIs that developers can use. But rather than talk about every single one of those APIs, because there's lots to cover inside them all, let's touch on some of our favorite capabilities, the things that really make developers' lives easy. So what are some of the things that you would mention that have been developed inside Dapr, that some of your favorite things that you would put out as sort of the standout capabilities?
Well, that's a difficult question because, we released over 100 features, I think, since we released Dapr 0.1 just, 2 years ago. So that is a pretty difficult question. Instead of starting off with what makes developers' lives easier, I want to talk about maybe features that make developers sleep better at night. And for me personally, that's our introduction of mutual TLS and automatic cert renewal. So when you're writing your application, you don't necessarily want to know or deal with the infrastructure for securing your applications end to end. And with the Dapr service invocation building block, we introduced end-to-end authentication based on SPIFFE, which is a CNCF standard, to basically carry over IDs for different services, which allows them to create access lists and, of course, have the data that's passing between services being encrypted in transit. And, of course, all of the certificate management is just taken away from developers, and it's being handled and rotated automatically by Dapr. So yes, it makes your code secure, and ops people don't need to actually manage the certificates renewal. So I think that's something that's I'm pretty excited about. And then, of course, I've been talking to Ryan Nowak, our .NET SDK maintainer, for quite some time. And for months, he's been coming to me saying, Yaron, our gRPC experience is actually not that good because we require developers to let go of their existing gRPC services and adopt our model, and it's not so native to gRPC. And at the time, I basically told him, yeah, I hear you, but we have other things to concern ourselves about. And over time, the community was really, really insisting that we provide a native gRPC experience. So the next favorite feature of mine, at least, is our gRPC proxying experience, which really allows developers to take their code as is and just hook up Dapr into it. All they need to do is just change from their hard-coded DNS address or IP to the Dapr localhost, and then you get observability, distributed tracing, connection resiliency, and mutual authentication all the way through. And it works inside of Kubernetes and outside too. Also, state sharing, I think, for me, is a really important feature. Dapr is also a set of best practices that are given to developers. And in a microservices environment, you don't necessarily want one service to be able to access the data of another service. So by default, Dapr will encapsulate the data for each service. But our friend from Alibaba introduced a really good feature that actually gives developers choice in deciding how to share state between services. So with that feature, you can encapsulate data for every given service, or you can create groups of services that share state, or you can just decide that all of your services actually get the same state. And that, to me, is also a really useful feature.
Yeah, that's a pretty good set of features. Actually, returning back to the security pieces that you referred to in the MTLS, and I think that Dapr is focused greatly on sort of enterprise security. Not only does it allow you to do MTLS between the services themselves, but also I think the ACL capability where you can restrict one service talking to another, the access to particular components from a service, the restriction on what you can publish and subscribe to. And also when you're talking about donations and Alibaba doing their work, I think the secrets API that was also donated from the community early on, it was one of the early contributions that allowed you to abstract out secrets so that they can be held in secret stores, where I think was an important piece that allows the separation of secrets from your code. Another one actually I would mention was just the console integration done by Man Group. And I think that piece of work that allowed console to do DNS resolution, and that really enabled Dapr now to run on hosted environments where there's a set of VMs that's independent of Kubernetes, and you can do the DNS resolution. So now you can do it on like your premises or on hybrid environments. I think that was an important piece. With some of the console integration, what were your thoughts on that?
Yeah, I think it's really awesome because, first of all, it allowed us to decouple Dapr from the platform it was running on. So, we had a Kubernetes DNS and we had we had multicast DNS for running on just any kind of environment, right, in VMs. And when we were running Dapr self-hosted, we would default to MDNS, and on Kubernetes, we would default to Kubernetes. So the first thing that that contribution from Man Group did was basically allow us to write pluggable DNS resolution components into Dapr. And then, of course, it allows you to create this flat network that can span between different Kubernetes clusters or between Kubernetes clusters and on-premise environments too. Also, between developers' local machine and a remote Kubernetes cluster in any cloud. So I think that really helps in connecting services in distributed environments.
Well, let's now hear from the next company, Alibaba. Alibaba is part of the Dapr steering and technical committee, and they've made significant contributions to Dapr, including using it in several of their projects internally. So I have with us today Ian Luo from Alibaba to share his perspective of how they see Dapr and how they use it internally. So Ian.
Thanks, Mark. We at Alibaba started adopting Dapr back to 1 year ago. The most valuable feature Dapr attracts us is just as it declares. Focus on your application's core logic and keep your code simple and portable. We found it fit into our internal function computing platform very well. In my opinion, an ideal function computing platform should be able to provide language options as many as possible. But before Dapr came out, we can only offer one language support, which is Java in our case. And this is because the backend services inside Alibaba usually provide Java-based SDK only. The demand for more languages is strong and has always been there, and Dapr came to rescue. Now, Dapr has become the default application runtime in our platform, and on this platform, we are now having applications running in 4 languages, including Java, Golang, Node, and C++. And we are confident to offer new language support very quickly, even before users ask for it. Of course, in order to achieve this, we did lots of work to integrate the internal infrastructure softwares into Dapr and contributed part of our work back to the community when we saw it fit. We use the Dapr in other scenarios as well, but I will not go into details today. Now, we are about to explore how Dapr can be helpful in the area of edge computing, and I believe it will become another interesting journey to us. Last, thanks again, Mark, for having chance to share our view on Dapr and how we use it inside Alibaba. We are very glad that Dapr is now being donated to CNCF, and since by doing this, we believe more and more people in China will get to know Dapr and start using it. Finally, we also hope more and more engineers can join this community, contribute to this project, and build Dapr a success together.
Well, thanks, Ian. Now let's talk about community. And the community contributions and engagement that have been made to Dapr is a super important part of its growth. First, let's talk about what we are seeing inside the community. As you can see on the slide on the right, that Dapr's community has grown enormously since its first inception. We have close to 15,000 GitHub stars. There's over 2,500 members on the Discord channel, all actively helping each other. There's over 200,000 page views each month on the Dapr documentation. And all of those have really helped grow the community. But I think the most important part is that ever since the very beginning of Dapr, through all of its preview releases and recently from its stable release, the community has always contributed directly into each one of the releases. And earlier this year, we had Dapr 1.0 release come out. And that was a significant milestone because it showed to the community that Dapr was ready. But we couldn't have done that without the adopters who took on early bet on Dapr, used it in production, used it in test environments, and they helped enormously get Dapr to a stable 1.0 release. So we want to say thank you greatly to all of those early adopters who took a bet on Dapr to enable everyone else to sort of build out and take Dapr into production. And so now we see many customers running in production and in test environments, and each of the releases up until the most recent 1.4 release have included significant features from the community, and we continue to keep this momentum going for the future 1.5 and 1.6 releases going out. So the community is very important. Yaron, from the community perspective, what would you like to kind of touch on there in terms of where the contributions have been?
The contributions have been all over the place. Dapr Runtime, our components contrib, or CLI developer tools, our different SDKs. We've seen the community even create new SDKs. The JavaScript SDK is really a good example of that. Also the PHP SDKs, our beloved maintainers, Xavier and Rob, doing an awesome job for these. For me personally, if I look at Dapr components, which are really the extensible point of Dapr and what provides this code portability aspect for Dapr, is an area that has seen the most contributions, I think. When we released Dapr, we had, 7 or 8 components, and now we have over 80. And the greater majority of them have been contributed by the community. And when I say community, I mean not the Dapr maintainers. So that to me is amazing. We're seeing a lot of components from GCP, AWS, Azure, and also just general open source components. And that really helps Dapr be this portable runtime that can take your code anywhere.
Yeah, and I think those are super important, including as all the contributions. I think they said there's over 80 components now.
Yep.
So with that, what we're going to do now is let's hear from our next company. Let's hear from Intel. And Intel are also part of the Dapr Steering and Technical Committee, and they're a leader in cloud and server technologies. And I'd like to introduce Mark Skrapness to share Intel's views on how Dapr have contributed to the cloud native space and some of the investments that they're making into the Dapr project. So Mark.
Well, thanks, Mark and Yaron. I lead the system software engineering team at Intel, and we've been following Dapr for a while, and it really appeals to us because it helps developers build complex distributed applications more easily and run them across the cloud and the edge, building them in the language of their choice, and with portability, taking on this goal of any language, any framework, anywhere, which we think is a great goal to work towards. So we're very excited to join the Dapr Technical Steering Committee, and of course, to be an active member of the community. And one of the areas that we've been exploring is bringing hardware acceleration to Dapr. We've been building lots of cool hardware accelerators into our platforms, and we've been looking at how can we bring the value of those accelerators to the developers and users of Dapr. For example, fast and secure communication is, of course, core to running a distributed microservices-based application. And we've already been making some contributions in this area. And now we're working on bringing support for some of our hardware accelerators that can make this work better, faster, and more securely. For example, we have our Quick Assist technology, or QAT, that provides crypto acceleration and data compression offload. And we've also added crypto acceleration instructions to our latest third generation Intel Scalable Xeon processor. So we're working on how can we bring the value of these accelerators and use them inside of Dapr to give the developers and users a better experience. Now, of course, this is really just a start. We're very much looking forward to working with all of you in the Dapr community going forward to continue to deliver on the promise of Dapr and work towards truly achieving the goals. So thanks, and look forward to working with all of you.
Thanks, Mark. Okay, Yaron, let's look towards the future of where Dapr is going and some of the things that we see on the horizon for the next year. What excites you about in terms of the features and capabilities that we're going to build next and some of the project's direction that's going in?
Another good question. I think there's three major features that I would call out here. One is the current proposal for the configuration API that we've actually just landed on for design, and it's going into implementation. So the configuration API is extremely important because it'll allow developers to just consume configuration from their apps, no matter where their code's running, and hook up into all of these different configuration providers, and also be notified whenever a configuration item changes. So that's just another really useful API that we're going to surface up to developers. The second one, I think, is the distributed logs API, currently driven also by the larger community. And this is going to allow for things like very easy leader elections types of applications. So if you have a bunch of services, you'll very easily be able to tell which one is the elected leader and basically just grab a lock. And that'll be supported on Kubernetes, on-prem, and really in any type of environment. So that's going to unlock a bunch of stateful scenarios for Dapr, which I think is also really important. And then something that we've heard a lot from the community is about how the key value API model of Dapr is kind of limited in that you can't query state. And developers have been very vocal about that pretty much since the beginning of Dapr. And I'm really happy to see that we've made good progress in designing for two sets of APIs. One of them is a query API, where developers will be able to query state that they saved using the Dapr state APIs. And then we're also targeting a more general purpose database API, which will allow Dapr to offer this SQL-like abstraction, if you will, for any type of data that's saved in any type of database. So again, I hope that these features will just make Dapr a lot more usable for stateful applications.
Yeah, those are some pretty good insights. And I think all of those new APIs, will expand, Dapr's capabilities enormously. Let's talk a little bit about some of the future direction of the project. One of the most frequent questions we get asked is, where is Dapr going in terms of donation to foundations, and how's the project kind of growing? It's sort of in the broader industry and the ecosystem. And so earlier this year, actually, we donated Dapr into the CNCF back in March, and we donated it to be contributed as an incubation project to CNCF. And it's slowly been working its way through the process there. And we're at the stage now where it's getting close to public open comments around these things. So we're super excited that Dapr is going to go, hopefully be accepted soon into CNCF and have the support around that, and you see the growth within inside that. So what are some of your perspectives and your thoughts on the CNCF work, Yaron?
Yeah, of course, the CNCF donation is extremely important for Dapr, just to gain these new audiences and have a more diverse outset of maintainers joining the project, and of course contributors from other projects contributing to Dapr. So that's going to be really useful for Dapr in that sense. But I also want to talk about our commitment to open governance. And we've announced a open governance steering committee even before we donated Dapr to the CNCF. And what we mean by that is that we are really trying to make the project vendor neutral and encourage participation from multiple companies and vendors to really ensure that Dapr solves for everyone's concerns. And then recently we announced the Dapr steering committee, on which both you and I sit, along with our friends from Alibaba and Intel. And to me, that's just a really good sign for our commitment, Dapr project's commitment to vendor neutrality.
Yes, and and to conclude on some of the direction of that project, I think those steering committees is extremely important to kind of help the inclusiveness around these things. But I also thought it was very insightful in some of the review of the Dapr donation, talking about Dapr and the API standardization. Okay, Yaron, give us some of your insights into Dapr as an API and some of the way that the CNCF were looking at that.
Yeah, so as the project moves forward, actually I'm looking forward to separating the APIs from the implementation and really making the Dapr APIs the center of focus going forward. So you can think about maybe even different implementations of those APIs. And once we separate those out, we'll be able to improve these and even provide, alpha implementations or other types of implementations that don't necessarily find their way into the core Dapr project today. And that's going to allow for multiple platforms to maybe adopt the APIs and have their own implementations, which I think is going to help developers adopt Dapr in a much more natural way in other environments.
Yeah. Well, it's been fantastic having a chance for both Yaron and I to share our perspectives and insights with you today in this keynote. We're super excited about being able to speak to you today. We want to thank all the speakers from Microsoft, Alibaba, and Intel for giving us their insights to see where they think Dapr is going. And for all of you who've been involved and contributed to the project in the Dapr community, thank you very much. And if you haven't yet, we deeply encourage you to get involved, give us your perspectives, and you can see some way of contacting us through the links on this slide. Please enjoy the rest of the conference. Please attend the rest of the sessions on YouTube. We've got a lot of great content, a lot of great speakers for you to spend the rest of the day learning, and we want to thank you for your time.